everyone, myself Neha Shah from LG Institute of Engineering and Technology from the Department of Electronics and Communication Engineering. Today I am going to explain more properties of discrete time Fourier transform from the unit of discrete time signal and systems in the frequency domain analysis from the subject of digital signal processing. Up to last session, I had explained what is DTFT, what are the uses of the DTFT, and we have started some properties of DTFT, right? In the last session, I had explained you three different properties. The first one is linearity property, the second one is time shifting property, and the third property is frequency shifting property. Now, if we will taking different properties, so for different properties, first of all, we will writing a statement, and then we will proving that particular statement. So for the different properties, in the proof of it, we will starting with the equation of discrete time Fourier transform, and then we will apply the rule of that particular property. And according to that rule, after rearranging the terms, it will give you the final term which will be considered as statement for that particular property, right? So now if we take in the next property is time reversal property. Now what is the meaning of time reversal? Time reversal is also considered as time folding or time inversion. Its meaning is whatever is positive side, it will flip in the negative side, and whatever will be in the negative side after folding, it will be on the positive side. So if we are taking this kind of operation like time folding, so what will be the corresponding DTFT in the frequency domain? So for that we will taking the statement of it. So for that, first of all, it will taking the input signal x of n, and if we will finding DTFT of it, then it will consider as x of omega. If we will taking the time reversal term x of minus n, then its DTFT will represent it by x of minus omega. Now, if we want to prove this property, so in the proof, we will starting from the equation of DTFT of x of n. Now, as you know that what is the equation of DTFT? DTFT of x of n equals to x of omega, and its value equals to summation n equals to minus infinite to infinite x of n into e raised to minus j omega n. Right? Now, we have to find out the value of DTFT of this x of minus n. So, if we want to find out DTFT of x of minus n, so instead of this x of n, we are taking x of minus n. So the term will be like this: summation n equals to minus infinite to infinite x of minus n e raised to minus j omega n. Now as you know that if this kind of term will be there, then instead of this term we will taking any another variable like n. So if I am taking any another variable like n, so let we are taking minus n equals to n. So what will be the range of this new variable n? So if we want to find out the range of n, so instead of this n equals to minus infinite, we will put in m. So the term will be minus infinite, so the value of n equals to infinite. Now if we are taking the value of n equals to infinite in this equation, so minus into infinite, so the value of n equals to minus infinite. Right? So the range of n will be infinite to minus infinite instead of n equals to minus infinite to infinite. So we are writing next equation as summation n equals to infinite to minus infinite x of n into e raised to j omega n. Instead of this minus n, we will consider it as n. So this minus sign will be removed after shifting it into the another variable. Now, if we are saying the summation is of infinite to minus infinite, it means if we are taking summation from minus infinite to infinite or infinite to minus infinite, the answer of it will be same. How? Suppose if I am taking 1 plus 2 plus 3, or if we are taking 3 plus 2 plus 1, the answer of summation will be same, right? So instead of this summation n equals to infinite to minus infinite, we can write like this: summation n equals to minus infinite to infinite, x of n will be as it is, and we will rearranging this term in the form of e raised to minus j omega n term. It means we have to convert this term in the form of e raised to minus something, right? So for that I am writing e raised to minus j into minus omega into n. So it is considered as minus minus plus j omega n, right? So we have rearranged this term like this, e raised to minus j into minus omega into n. Now if I am writing over here like this omega, so it will representing as x of omega, but here the term is minus omega, so this particular equation we consider as capital X of minus omega. It means it will representing in the frequency domain in the folded form. So it will representing like this x of minus omega, which we want to prove. So this way we can prove the time reversal property. Now the next property is differentiation property. Now for the differentiation property, it will write in the statement. So for that, first of all, we will taking DTFT of x of n, so it will representing by x of omega. Now if you want to do the differentiation in the frequency domain, so in the frequency domain, the term will be representing like this x of omega, right? So it means it will consider as x is a function of omega. So we have to take the differentiation with respect to omega. So this term will representing as d by d omega x of omega. So if we are taking the differentiation in the frequency domain like this, j d by d omega x of omega, so what should be the corresponding term in the time domain? In the time domain, the x of n will be multiplied by n, so it will gives you the differentiation in the frequency domain. Okay, so this one is the statement, n into x of n, its DTFT will be j into d by d omega x of omega. Now, if we'll taking the proof of this particular statement, so for that, first of all, we'll starting with the equation of DTFT. So as you know that the equation of DTFT is DTFT of x of n equals to x of omega equals to summation n equals to minus infinite to infinite x of n into e raised to minus j omega n. Right. Now, we have to take this term d by d omega x of omega. So this term is considered as x of omega, right? So if we are taking differentiation on both the sides, so it will representing this term will representing as d by d omega x of omega equals to d by d omega summation n equals to minus infinite to infinite x of n into e raised to minus j omega n. Now here we will apply the next rule. Which one is, suppose if there will be two summation, summation integration, summation differentiation, likewise, so we will rearranging the order of it. So it means this summation goes over first and this differentiation comes at the last position. Okay, so after rearranging the order of it, it will be representing like this summation this d by d omega this. Now whichever term will containing the omega, so it will be inside this differentiation. So x of n is constant, so it will be outside of this differentiation, but it will be in the form of n, right? So it will be inside this summation. So it will representing as summation n equals to minus infinite to infinite x of n d by d omega e raised to minus j omega n, because this term containing omega as well as n. Now first of all, we are taking the differentiation of this and then we will apply the next rule. So the next term is d by d omega x of omega equals to summation n equals to minus infinite to infinite x of n, and the differentiation of e raised to minus j omega n is minus j into n into e raised to minus j omega n, right? Why? Because we have taken the differentiation with respect to omega. So this minus j and n terms will be considered as constant. It will be as it is over here. Okay. Now if we simplify this term, so minus j term will be constant, so it will be outside of the summation. Then the summation n equals to minus infinite to infinite n into x of n into e raised to minus j omega n. Now, if we multiply by j on both the sides, so this term will representing as d by d omega x of omega into j, and over here the term will be minus j into j. This term will remain as it is. Now, as you know that j into j means j square, and the value of j square equals to minus 1. So this minus into minus 1 become considered as, so this minus 1 into minus will consider as 1. 1 into this term will gives you that term only, right? So this term will representing as summation n equals to minus infinite to infinite n into x of n into e raised to minus j omega n. Now as you know that the equation of DTFT is summation n equals to minus infinite to infinite x of n into e raised to minus j omega n, right? So instead of that x of n, over here the term is n into x of n. So this particular term will be considered as DTFT of n into x of n. So if we are taking DTFT of n into x of n, so it will gives you j into d by d omega x of omega in the frequency domain. So this way we can prove the differentiation property. So here we have taken the differentiation in the frequency domain. Now the next property is Parseval's theorem. Now what is Parseval's theorem? So first of all, if we are writing the statement for that, so for that we will taking two different input sequence x1 of n and x2 of n, and if we will finding DTFT of it, then it will consider as x1 of omega and x2 of omega respectively. Then the summation n equals to minus infinite to infinite x1 of n into x star of n means conjugate term of x2 of n is equals to 1 by 2 pi integration minus pi to pi x1 of omega into x2 star of omega d omega means conjugate term of the second. The Parseval's theorem meaning is like this: if we are taking summation of multiplication of two input signal, then the corresponding to that output will also give you the multiplication of that two corresponding DTFT sequence. So in the proof of this Parseval's theorem, we will starting with the equation of inverse DTFT. Now if we are writing the value of x2 of n, so it will consider as it is finding by taking inverse DTFT. Now what is the equation of inverse DTFT? For that, first of all we will taking DTFT's equation. So what is DTFT? Suppose if I am taking DTFT of x of n, so it will gives you x of omega, right? But here we have to take inverse DTFT, so it means from x of omega value we will finding x of n. Why we are taking like this? Because we have to find out the value of x2 of n. It means if you want to find out any signal in the time domain from the frequency domain, so for that we will taking inverse DTFT. So here if we are taking x2 of n, so its value will be 1 upon 2 pi integration minus pi to pi x2 of omega e raised to j omega n d omega. Now here the term is x2 star of n, it means conjugate term of x2 of n, right? So if we want to find out x2 star of n, so we will taking conjugate on both this side. So x2 of n will convert in the form of x2 star of n. So its value will be 1 upon 2 pi integration minus pi to pi, range will remain as it is, and instead of this x2 of omega it will consider as x2 star of omega, and instead of this e raised to j omega n, its conjugate term will be representing as e raised to minus j omega n d omega, right? Now if we will putting this value x2 star of n in this equation, so corresponding to that it will give you the output like this. So we will finding that value. So if we are taking summation n equals to minus infinite to infinite x1 of n, x2 star of n is equals to, instead of this x2 star of n, we will put in its value. Its value will be written in this square bracket. So I will write this summation as it is. So summation n equals to minus infinite to infinite x1 of n in bracket 1 upon 2 pi integration minus pi to pi x2 star of omega into e raised to minus j omega and d omega. Now here we will applying that rule. If summation integration will be there, then we will rearranging the order. So we will taking this integration first and then we will taking summation at the second position. Now as you know that the summation is of n, right? So we will taking the term which will containing n. So we are writing like this: summation n equals to minus infinite to infinite x1 of n into e raised to minus j omega term over here, and all the other terms will be outside of this summation. So 1 upon 2 pi is constant, so it will be outside of this integration as well as summation. So 1 upon 2 pi integration minus pi to pi, this x2 star of omega into this term into d omega, right? Now from the square bracket, if we will comparing this equation with the equation of DTFT of x of n. So what will be the value of DTFT of x of n? Summation n equals to minus infinite to infinite x of n into e raised to minus j omega n, right? It means if we will find DTFT of x of n, so it will gives you x of omega, right? Here, instead of x of n, we have taken x1 of n. So this particular square bracket will representing the term x1 of omega. So instead of this, if we are writing x1 of omega, so the term will be like this: 1 upon 2 pi integration minus pi to pi x1 of omega x2 star of omega d omega. So this way we can prove the Parseval's theorem by rearranging the terms. In the next session, I will explain more properties of DTFT. Thank you so much.